ever change that. So we can only change this, we can only keep this constant, this constant, this or this. In this case, we're going to say at constant temperature. Okay? That means T is going to be the same. Okay? That means if T is constant and then N is constant, we're going to keep two things constant here, at constant temperature and at constant N. Okay. Constant moles, which is N. You always keep two things constant and change one and vary the other. Because you know it's very difficult to change two things at the same time. That's very, very difficult. So the first situation is constant temperature, constant N. That means this equation simply reduces to, if you want to do the math, it's P1. I'm going to write it this way. If any of you are interested, I'll solve it a different time, but that's not the point of this. P1, B1 equals P2, B2. Okay. If I keep this constant, if you wonder how I got this, because I am going to change one and keep the constant for the other one. So this equation reduces down this. Okay. P1, B1 equals P2, B2. Now if you wonder how I solved it, that's a game.
Well, how did you get the P2 and B2?
That's because in two different temperatures, two different pressures. That's what that means. This is an equation.
Oh, okay.
P1 is pressure 1. Okay, it's not means at one pressure, one condition of pressure. B1 means volume under condition 1. P2 is pressure under. Again, I'm going to explain it, so that's not something.
We have to know that right now.
What's that?
We have to know that right now. I mean, like right now.
You don't need to. Since you asked where the 1 and 2 comes from, now, if you have a balloon and you try to squeeze it, you're adding pressure, right? You're increasing pressure. What happens to the balloon? I mean, you will try to get back to the normal, but then the volume decreases, right? So the rule here is, if you increase, as I said, the up arrow means you increase. If you increase pressure, volume decreases. If you decrease pressure, volume increases. The contrary is always true. You don't need to remember both. Just remember one, you can remember the other. Now I'll try my best to give you this equation, but I'm still debating on it. But don't worry about it. If it gets to a point that's a problem, we'll decide that. So we're going to do a problem here from the homework. Now again, for these type of problems, you don't need to do a lot of conversions, no molecules to atoms and all those crazy stuff. This stuff is much easier. So this is just going back to the balloon. If you squeeze the balloon, you're adding pressure from the outside. So you're increasing pressure, volume will decrease. Okay? For anything that you can think of in your real life, if you increase the pressure, like you want to pack something in your, like in a container or box, you try to squeeze to put as much of it in there, right?
Mm-hmm.
You're trying to reduce the volume each time, so you have more space to add more, right? I think before the priority mail and all that box mail came from USPS, shipping used to be very expensive in the States.
Pony Express.
What's that?
The Pony Express.
Before they came up with the idea, just pay $5 flat rate, put whatever you want in that box. Since that
No, we
time,
didn't get it.
the shipping on eBay and Amazon, they all went down. You see so many items on eBay and Amazon are so cheap, right? And they also give you free shipping. Just because of that, because USPS at one point was going to go bankrupt and they had to find, that's pretty strange, right? A government agency going bankrupt. And
No.
a company going bankrupt is perfectly all right, but a government agency cannot go bankrupt. So they said, how are we going to, they lost employees. They were firing employees left and right at USPS. And they were going to lose USPS. The US government was going to lose USPS for good. That's when they said, well, we're going to make some deals with other agencies like FedEx, UPS, DHL, and then we also going to come up with this flat rate shipping, economy shipping, and all this crazy stuff. That's when they we're actually able to pop back up and hire more employees. And if you all use UPS service or FedEx services, sometimes UPS delivers the package. Does anybody have that? Like you ordered through an UPS and USPS delivers the package.
Yep.
The stamps went down?
Yes. So it's all part of it because
UPS deliver on Sunday too.
because
just said, yeah.
the reason where the issue started was because people were sending just this cup without any goal. They were sending stuff that doesn't have a perfect volume into containers that don't fit in, and carriers that carry that will charge more in terms of, well, I can only fit 4. If you had packed well, I would have put more in my container. So the gas costs contributed to it because people were not packing properly. So that's why USPS couldn't afford that. They came up with the flat rate boxes where you stuff it in. The reason is you're putting pressure inside that box to stuff everything in. Every time you push your hand, you're pushing stuff back into the box. You create more space, right? So that's a wrong stretched example. I'm sorry. That's a lame example too. So excuse me, but I don't want to talk in terms of these. I want to talk in terms of what you do, which makes sense to you. So you keep pushing, adding more pressure to put every single item into that box. So you're sending a lot of stuff for $4 than sending
The
one
garbage
thing
can.
for $5 or something. Still, I think it's expensive, but USPS is still cheaper than FedEx and BioChem, all those people. So going back to this problem, let me find one on here that's
Can we take like a 5-minute break?
Yeah.
after this problem.
Okay.
So I can finish this so I don't lose connection of. All right, problem 1.
This is number 1.
Yeah, problem 1. It says there's 22.5 liters of nitrogen. Again, you don't need to worry about, for this type of problems, you do not have to, you have to assume it's N2, but it really doesn't matter because we're not trying to do anything with moles here. Is compressed 25 liter of nitrogen gas at 748. This is another unit for pressure. Again, you don't, because we're not doing any conversion, just substitute the value as it is. What is compressed to, so I'm writing the question as text messages. So this was the initial volume and initial pressure. So this is V1. V1 and P1 are, 1 stands for initial, 2 stands for final, if that makes any sense. Now you don't need to do any conversion. As I said, ATM is universal. Again, in the US they do use millimeters of mercury pressure. So if you hear a Weather Channel reporter saying, oh, we have 720 mmAg in Lexington, don't get confused. He's talking in terms of American pressure units. And then it's compressed to 725 millimeters of mercury. This is pressure 2, and they're asking what is the volume. That means you're solving for V2. Now I'm going to go back to this and finish this problem before I give you that break. Okay. Because I'm going to erase all this. Because constant mole, because the question doesn't say anything about temperature or gas constant or N. If you don't remember this equation, or if you can't memorize it, there's a way to get to it. Is because we're only given 4 things. We know pressure, volume, pressure, and what is the volume. Which means we can simply write this equation for the rest of the cases. PV equals constant. I'm just going to follow with me and you'll be fine. Just bear with me on this one. So you read the question and you see, okay, I'm given volume, I'm given 1 pressure, I'm given 1 more pressure, and I'm asked for new volume. That means we're only dealing with 2 variables, pressure and volume. Write this as constant. Because as I said, you will always have initial of something, you'll always have a final of something. So P1, V1 equals constant. I mean, you do this after you read the problem. You cannot know what to do before you read the problem. So you have an initial pressure. As I said, 1 stands for initial, always in chemistry. 2 stands for final. Where you start with, where you end. Where do you leave your house is your initial, your classroom is your destination, which is final. You go back home, you go back to your initial. So write it this way, and then we know that we want to find the new, we are given new pressure and new volume. Because these two sides are equal, we can say that these two sides are equal. That's algebra. That is how I got this. That's only 2 steps. Okay? Now, you wouldn't be able to do this before you read the problem. First thing, you read the problem and write it the way I did. You don't need to even write it down. Right on top of the terms itself. This is meters, so that's got to be volume. This is a unit for pressure, and I will probably give you a list of units for pressures on the front page of the test. So even if you don't know what is this corresponds to, well, you know that's pressure 1. And it's gone to a new pressure, you decrease the pressure, P2, to ask for volume. So you know that you're only playing with 2 terms. So you go back to this equation, which also will be on the first page of your test. That's equal to constant. Because we have 2 pressures, 2 volumes, you write P1, V1. You cannot write P1, V2. That's incorrect. Okay? It's incorrect. You got to write P1, V1, that's equal to constant. If you write just constant, then I probably will give you this, and from there you can expand on this. I'll give you this for the rest of it too. Because these 2 terms are constant, they are equal. If these 2 are equal, these are equal. This is an algebraic theorem. Algebraic theorem. If 2 things on your right side are equal, the left side must be equal. That is like 6th or 7th or 8th grade algebra. That's an algebraic theorem that says if these 2 are equal, these 2 must be equal. So it's constant that has no meaning, so we can just strike it out and just write these 2 across. It's not like they're right next to each other. What it really means is these 2 things are equal, so this must be equal, so that's how I got it. So now let's go and complete the problem. So we know P1, V1 equals P2, V2. Don't need to do any conversions. We're given P1, so again, you can, some of you can see it, so I'm going to write it here. P1, V1 equals P2, V2. We know pressure 1 is 748. We know volume is 22.5. We know pressure 2 is 725. What is V2? So divide both sides by 725, multiply this, and can anyone get me the V2 value?
23.21. 23.21.
23.21.
23.
23.21.
Yeah.
So why don't you take a break and we'll come back and finish this stuff.
23.21.
Yes, 23.21. I have only really